Hi everyone, good afternoon. So finally we are back with one of the very great session on signal and system, and this is going to be lecture number 2, right? So I make assumption that you guys might have seen the lecture number 1, right? So linear algebra is going on, and uh, devices I have started. In fact, now the signal and system. If you're good at signal and system, then you will find comfortable. In fact, you will feel comfortable. While dealing with network theory, right, and as well as control system and communication system as well. Okay. So hi Tanisk, let's wait for people to join us. Okay. Then we will start the session for today's session, right? So I'm not going to repeat what we have done in the lecture number 1 in signal and system. I will be starting with the classification only, right? Yeah, namaste Devans. Yeah. So we have already done some of the basic things. What is signal? What is system? Okay, and we have classified signals like what is analog signal, what is digital signal. Okay, and what is continuous time signal? How we get continuous time? How we get discrete time signal from the continuous time signal? Okay, via one operation that is sampling operation, right? So I hope these things you might be familiar with. So today I'm going to talk about the next class of signal, you can say, is the deterministic signal, right? So yes, hi Subham. Yes. So basically today I'm going to talk about the deterministic signal, right? So let me make myself a small one first, otherwise you will not be able to see me properly. So I'm going to make it a small one so I can keep anywhere. Okay. Today I'm gonna keep myself on this corner here, right? So okay. So what I'm supposed to talk about is what is deterministic signal. Okay, deterministic signal, and what is random signal. Okay, how we call it random signal. So you guys can also write in the chat box if you know what is the meaning of deterministic signal and what is the meaning of a random signal. Yes, all of you can write, okay, because I'm also looking at your comment, okay, in my, yes. So the deterministic signal is nothing but a signal, okay, you can say xt or xn, xt or xn, right? Okay, that is completely specified, okay, that is completely specified, okay, at any given time instant, at any given time instant, okay. Or you can also say that if any signal is there, okay, if any signal is there and you are able to specify that signal at any given time instant, okay, that is going to be deterministic signal. Now many people think that if any signal is expressed in mathematical form, that is only going to be a deterministic signal, okay. But in future you will find that we will model, we can model random signal as well, okay, we can model random signal as well. So xt or xn, that is completely specified at any given time instant, that is known as deterministic signal, okay. So what is the meaning here? I'm just going to take some example here. Suppose we have got xt equal to sine t, okay, sine t. So suppose I plot it, okay, so this is sinusoidal, okay, and if I ask you that what is the value at this time in, suppose t at t1, what is the value of the signal, okay, xt, right? You guys can tell directly, right? So sine t is one of the example of deterministic signal. You can also say that xt is equal to e raised to power t, okay. These are the mathematical functions which are deterministic signal. But what is the meaning of random signal? What is the definition of random signal? Okay, if somebody is going to ask you that what is the meaning of in fact what is the definition of random signal, तो आप क्या बताओगे? The random signal, one of the very great example is the noise. A random signal, The great example is noise, and random signal basically takes random values. Okay, random signal basically takes random values, okay, at different time instants, right? Random signal okay takes random value, okay, random value at, you can say, different time instant, different time instant. Right? So this should be your definition of random signal. Okay, if you take you see here, this is the noise here, right? This is the noise, you can say. Okay, this can be a noise. Now the value, you see, the amplitude is at different time it is different. Okay, the random signal is taking random values, okay, at different time instant. But if you look at a sinusoidal, okay, if you look at sinusoidal here, so at t1 this is only the value which is specified. Okay, so xt or xn, that is completely specified at any given time instant. Okay, so keep this in mind. These are very important difference between deterministic and random signal, because random signal is going to play an important role in digital communication. Okay, in digital communication, when we will talk about digital communication, so there we will see random signal, because noise is one of the devil, you can say, common mode devil. When you send some message, okay, using some transmitter, you send some message. Okay, so in the channel what happens basically, along with the message, noise gets added, right? In fact, you will also find in digital communication one of the very good channel. That channel will be named as AWGN. Okay, additive wide Gaussian noise channel. Okay, so what happens, signal is going and the noise will get added up, right? Okay, this is very important. And at the receiver, you will not be able to identify that what was exactly sent, right? Or you can also say that random signal, suppose you are sending 0. Okay, so what you are expecting in the receiver end, you are expecting 0 only, but you will not get 0. Okay, you might get 1 as well. Okay, you might get 1. Okay, because of noise gets added in the channel. Suppose you are sending 1, what you are expecting in the receiver, you are expecting 1, but you will not get 1. Okay, so I think this kind of a picture you might have seen in communication system. How many of you have seen this in digital communication? I think somebody who belongs from electronics, they might have seen this butterfly diagram. Subham Sahi sir, can we say that sine t is random signal as t equal to infinity? It will oscillate between 1 and -1. See, it will always, sine function always takes the value between 1 and -1. What I'm trying to make sure here is that any signal, okay, which is completely specified for all time, okay, that you can say, okay, is the deterministic signal. Okay, and noise is what, my noise might be different. Okay, at t1 it might be different. You take temperature variation as well, right? So temperature variation is random. Okay, yes, this is basically binary symmetric channel. Okay, so only EC people can understand this, right? So how we are getting this is also named as butterfly diagram. See, I'm trying to send 0, but because of noise gets added in the receiver, I'm thinking, okay, 1 was sent, right? So there is some error. Because of that, one very important parameter we calculate in digital communication, that is probability of error. Okay, so let us keep this apart, because the signal is going on. So random signal plays an important role in different communication system, okay, like digital communication system and analog communication system. So please keep this in mind. So yes, so at infinity, then what should be answers, are deterministic or random? At t equal to infinity, you are asking. Okay, so as t tending to infinity, sine t will be what? Sine t is going to always take at t equal to infinity, we can't do. Okay, we always see what, t tending to infinity. Okay, so we have to apply the limit over there. But here what my definition is, remember, the deterministic signal is what? If it is completely specified, okay, so it is going to take two values only, between 1 and -1, right? So this question, I think, is your question is not okay. At infinity, this is completely different question, right? So you have to apply the limit here, okay? But the basic definition is what determine. Nobody is going to ask you this kind of question ki at t equal to infinity, whether sin t will be, deterministic or random. Sin t is deterministic always, okay? Keep this in mind. And the example for random signal I'm just going to give you is, one is the noise, okay? And one more example I'm going to use. Suppose example is x of n. X of n is going to take +1 and -1, okay? +1 means if outcome is head, okay? Outcome is head, and if outcome is tail, then we will assign -1, okay? Now see, x of n can take +2 as well, right? X of n can take any value. Understood, guys? So this is the random signal. From the random experiment, we are getting what? The random signal, okay? So I hope this makes sense. So this is one of the mathematical example I have given you, okay? It looks like a deterministic signal, but it is not a deterministic. It is going to be a random, okay? So x of n represents what? It represents a coin toss experiment, okay? So they will be asking you what is deterministic signal, what is random signal, that you have to answer, okay? So mathematically, you see here sin t, e raised to power t, all these guys are random, deterministic signal only, okay? So in case of when we talk about random variable, so they, what happens? We always assign some real number, okay, to the outcomes, okay? So though then we do a lot of mathematics over there, but still we feel that that is random, okay? But random is somewhat misnomer to that name, okay? Because we are assigning some value and we are solving the questions, right? So but it's okay, as the name suggests, you should understand the definition, right? So random signal, as the best example I told you, is the noise, okay? And noise is a common mode devil, okay? Because of this, in fact, we study noise in amplifier as well, okay? Low noise amplifier, I think you might have heard about that, right? So suppose we take about time, if we see, so this guy is highly random, like this, okay? So random in time, it is random in time, the noise is random in time, okay? Okay, so I hope this makes sense, right? So what is the limitation of noise? Noise basically limits the system performance, okay? Keep this in mind, it always limits the system performance, okay? So we have to understand how to characterize noise, and there are many things which I will discuss in digital communication, right? Not in this course, okay? So signal and system is just, I wanted to discuss the formal definition of deterministic and random. I hope this makes sense. Next kind of classification is going to be the even and odd signal. Even and odd signal, okay? So I will take various examples as well, don't worry, I will solve some questions as well, but let us cover some of the concept first, right? So even and odd signal, what is even signal? I think you might be familiar with even function, right? So what is the definition here? For even signal, if x of t is equal to x of minus t, so this is known as even signal, okay? Suppose you are replacing t with the minus t, or you can say that if you are flipping time, okay, if you are flipping time, so that should be what? Same, okay? So you can say that suppose this is a signal, okay? This is a signal x of t, okay? This is -2 and this is 2, right? So if you flip about y-axis, so you're going to get the mirror image, right? So what is this? This is the definition of even signal. And if I say that, what is odd signal? Odd signal is going to be, suppose you have been given xt, and if you replace xt with x of minus t, okay? So if you can say, if you you can say put the minus t here, right? So what will happen is that it should be equal to minus of x of minus t. So this is the definition of odd signal, okay? This is a definition of odd signal. If I ask you that whether sine t or cos t is what? Cos t is even signal or odd signal? Suppose I take one example here. Xt is equal to cos 2 pi ft. Is it odd or even? So what we can do here is we can find out. X of minus t is going to be what? Cos of minus 2 pi t, okay? Because you have to replace t by minus t in order to test whether the given signal is even or not, right? So what is cos of minus theta? That is cos theta only, right? Okay, so you see here this guy is x of t only. So remember, this is always even. This is always even. So in the question they will mention xt is even and real signal, okay? Most of the time in the question you will find this kind of a statement, xt is real and even, okay, in future. So xt is real valued. If they are saying xt is real valued, means xt can take only real values, okay? It cannot take any complex value. Remember this, okay? In the exam they will mention xt is real valued function or xt is real valued signal. This kind of word is mentioned, real valued, okay, real valued signal. So if xt is real valued signal, can it be even as well? So you have to test, okay? So what is the test here? You have to replace, you have to take x, you have to replace t by minus t and then check whether it is xt equal to x of minus t or not. I hope this makes sense, okay? And if graph is given, by looking at the graph you can always tell, right? So suppose we have been given a graph of cos t, right, like this, okay? Naturally we are able to see that about this y-axis there is a mirror image, you see, okay? For positive time, for negative time, it is okay, there is a mirror image of that, okay? So this is a even signal. I hope this makes sense to you. And if I talk about, so you see, this is for continuous time, right? The same definition goes for, yes, same definition goes for discrete as well, x of n, x of minus n, right? So this is for even, and x of n and equal to minus x of minus n. This is for odd, okay? This is for discrete time signal. I hope this makes sense, guys. So keep this in mind, these are very important concepts. In fact, when you will find in the question, okay, xt is real valued signal, so you will say, what is this? Real valued means xt can take only real value, okay? Okay, x of n can take only, no complex numbers should be there, okay? And the example, best example for odd is what? Somebody is telling, I guess, sine as odd, right? So you can say example for odd, right, will be what? Xt equal to sine t. So I need not to prove it, okay? I need not to prove it, okay? And one more thing I am going to tell you guys, any signal can be written in terms of even part and the odd part, okay? This is also very important thing. Suppose any signal is given xt, so any signal has even part as well as odd part, right? So any signal can be decomposed into even part, okay? So you can say that this is even part of t, xt, and this is odd part of it, okay? Any arbitrary signal, any arbitrary, right? Okay, real valued signal, okay, can be decomposed into even part and as well as the odd part. Now the question is how to find even part of the signal. How to find even part of the signal? Suppose any signal I have given you. I have given you a unit step signal, okay, or a unit step function. Okay, I will explain what is unit step function, but suppose I have given you unit step, right? And I'm asking you what is the even part of this. So how would you determine? Suppose we have got, let me go to next page and tell you here, right? So xt equal to x of even part of t plus odd part of t, right? So you can replace this by minus t, okay? So this is the first equation. So this is x even minus t plus x odd of minus t. Okay? Now everybody knows that what is x, if x is even, right? So this is going to be simply what? X of even only, right? But if it is odd, so it became negative of that. I hope this makes sense, right? So this is x of minus t. So this is second equation. Now if you want to find what even part of this, what is even part of this, you have to add it, right? So just add equation 1 and 2. Add equation 1 and 2. Okay. So you have to do the same story when any signal is given, particular signal. First replace that t time with minus t, then add and subtract, okay? So here if you add this, okay, you see here this odd and odd part will get cancelled, right? And this is x even, that is 2 times of x even part of t is equal to x of t plus x of minus t, okay? Now from here you have got the formula. What formula you have got, guys? Here x of even part of, or you can say even part of xt is equal to, first of all you have to take x of t plus x of minus t by 2. So this formula you have got, and I have shown you how to find this formula, okay? How to determine even part of xt. This is the case, okay? Even part of xt can be determined by x of t. Just take signal, given signal, then write the reflection about y-axis, okay? That is x of minus t. This is just a reflection, or you can say scaling by minus 1, and by 2 you have to do, that's it, okay? I hope this makes sense to everyone. Yes? So if I ask you what is the even part of sine t, let me take one example here. So can somebody tell me what is the even part of sine t? X of t equal to sine t. So what you have to do? First of all, if you want to find even part of sine t, so sine t you write here plus sine of minus t you write here by 2. What is this? Since we know that sine t is basically a odd signal, okay? Yeah, ft plus f of minus t by 2. If sine t is basically a odd signal, so even part will be 0 in this case, okay? So this is how we find, always simple, okay? If I ask you what is the odd part of cos t, right? Okay, or you can say even. So first of all, even part we have calculated. How to find odd part of any signal? Tell me here. So what you have to do, odd part xt can be calculated with the help of this. You see here what we have to do. Equation 1 and equation 2 we have to subtract. What? Equation 1, just subtract equation 1 and equation 2, right? So in order to find odd part of xt, you have to subtract equation 1 as well as equation 2. Okay. I think everybody might be familiar with this. So x odd part of t is going to be x of t minus of x of minus t by 2. Simple. So these definition, I think everybody might be familiar as well, right? So signal and system is highly mathematical, okay? Okay, I hope this makes sense. Everybody understood how we are getting these formulas? Now this is your there will be your job. You have to solve the question. So we will take in the next session only one exercise. Okay, first of all, I'm just covering some concept, then I will take one exercise from Oppenheim and we'll solve all the questions, right? Some important questions, okay, in the next session only. So now the next concept is, next kind of classification is periodic and aperiodic signal. Okay, periodic and aperiodic signal. So remember, I think you might have seen periodic function in mathematics, in calculus, aperiodic signal. Okay, so this is a question of periodicity. Okay, this is a question of periodicity, right? And this is one of the very important classification. Very important classification. Why? Can somebody tell you why we are saying that this is very important classification? Because you know, in future you will study some tool, okay, to analyze system and signals. Those tools name are like Fourier series, you know, Fourier transform, the Laplace transform, the you can say G transform, okay, for different sort of signal, like continuous signal. If there is a discrete time, so you have to go for G transform, okay. And we will also talk about discrete Fourier transform, discrete time Fourier transform, right? So this year question was also there, okay. If this Fourier transform is periodic and this, so what will be the, you know, whether it will be complex or odd, whatever, okay. So there is some story, but we need to study first what is periodic signal and what is aperiodic, you know. Yes, Devans, whole signals is based on periodicity. Great. In fact, when you go for DFT, right? So everything, you know, your range of vision will be what? 0 to 2 pi only, or you can say 0 to pi. Okay. If you're going up above the range of vision, then you have to make yourself adjust circularly, right? That you know. Okay. So range of vision is always fixed. You know. For continuous, range of vision is from minus infinity to infinity here, but for discrete time, your range of vision gets limited. Okay? So, we will discuss everything, don't worry, but let us build our concept. Periodic, okay? So how can you say, how can you claim that xt is periodic? What is the formal definition? So xt is periodic. Xt is periodic if and only if xt is equal to x of t plus capital T. Xt is periodic if and only if xt equal to what? Xt plus capital T. What is capital T? Yes, Devang. DFT is very fascinating. If somebody is working in a, you know, industries, they might you know, देखो आप लोगों को कैसे पढ़ना है, आप लोगों को ऐसे ही पढ़ना है, सारे क्वेश्चन बनेंगे. लेट मी फ्रैंकली टेल यू गाइस, ठीक है, ये मेरा एक्सपीरियंस है. यू नो, व्हेन आई वाज प्रिपेयरिंग फॉर गेट, रियली मैं बता रहा हूँ, मुझे नहीं आता था, ठीक है. आई यूज्ड टू थिंक व्हाई आई एम नॉट एबल टू सॉल्व, बिकॉज द थिंग इज आई वाज जस्ट ओके, टीचर हैज टॉट मी फॉर्मूला, मैंने रट लिया, खत्म. नहीं, ऐसा नहीं सीखना है. यू हैव टू प्रिपेयर अ बिल्डिंग ब्लॉक फर्स्ट, राइट, जिससे क्वेश्चन में अगर लिखा है कि ओके xt is real valued signal, तो हमें समझ आना चाहिए xt मतलब xt can take only real value, it can not take complex value. Okay, so these sort of concept you have to be making strong, right? Okay, so xt is periodic if and only if it is defined like this. Okay, xt is equal to xt plus capital T. What is this capital T? Capital T is basically a, you can see, smallest time, okay, that is known as fundamental period. Okay, that is known as fundamental period. Okay, so there exists time capital T. Okay, this guy, okay, there exists a time capital T, okay, for which such that you can say such that xt plus okay is periodic. Okay, so let me show you here. There are some properties. Xt, okay, if signal is periodic, remember, if signal is periodic, first of all, it should be everlasting. Okay, everlasting signal. Okay, it should never last. Tanisk, what I should tell? Okay, so periodic means, suppose I ask you that, is it periodic? Is it periodic? Okay, if I ask that, is it periodic? It is not periodic. Okay, because periodic signal should start from minus infinity and it should go to infinity, right? It should be everlasting. It should never last. See, it is starting from zero onwards, right? You can't say this is not periodic. Not periodic. Okay, so it is not periodic signal. Keep this in mind. This is very important definition. Okay, so what is periodic then? Periodic means after each time interval, after each t, it's the signal gets repeated. You can say like this. Suppose this is one signal xt. Now after t time, it will be, this is the copy of xt, you can say, right? You see, they are getting repeated now, right? So you can say that we are starting from minus t, this is 0, okay, and then you can say this is t, this is 2t, this is 3t, and so on and so forth. Okay, so what is the time period here? The time period is basically this, and time period is basically this. Suppose this is one signal and these are the copy of the signal, right? Copy, you are just putting, okay, the replica of the same signal. So this is what the periodicity, okay, periodicity of continuous time signal, right? So let us take one example and understand the periodicity of continuous time signal. Let me warn you here, guys. If it is a continuous time signal, guys, you don't have to worry about anything. ठीक है? अगर ये continuous time signal की बात हो रही है, you don't have to worry about. You don't have to become cautious. Okay? There is only simple rule. But if there is a discrete time signal, okay, or a discrete time sequence, and they are asking, can you test the periodicity? So you have to be little cautious. ठीक है? थोड़ा सा cautious होना पड़ेगा. Blindly you can't say it is the given signal is periodic signal. Okay, in case of discrete time sequence, that's why I'm telling you, you have to be cautious, right? You have to put caution. Okay, so suppose example here for continuous time signal, xt equal to 2 pi sine 2 pi t. So by looking at this, you can say, yeah, sine 2 pi t is a continuous time signal. Okay, you can directly tell sine 2 pi t is a continuous time signal and it is a periodic signal. Directly you can say it is a periodic signal. You don't have to test. Okay, I hope this makes sense. You don't have to check, but still let us check. Okay, let us apply the formal definition. As we know that xt is equal to what? Xt plus capital T. So how to apply that? In place of t, you have to put t plus capital T, right? So just put here sine 2 pi and t plus capital T, right? I hope this makes sense, right? What is this? What is this, guys? What is this? You can say that sine 2 pi t plus 2 pi capital T, right? Okay. Now, if t is equal to, you take, if t equal to 1, right? Consider a small, okay, consider capital T equal to 1 second. So what is the value of sine 2 pi t plus 2 pi? Anybody? What is the value of sine 2 pi t plus 2 pi? क्या है? बताओ. What is sine 2 pi t plus 2 pi? It is going to be sine 2 pi only. Okay. After each 2 pi, the sign gets repeated. Okay. After each 2 pi, the sign gets repeated. Okay. So what is this? This is xt only. Okay. So you can say that sine 2 pi is a periodic signal. Sine 2 pi is a periodic signal. Okay. So how can you find the period? How we have got this period t equal to 1? How we have got? You know that xt is given as what? Xt is given as sine 2 pi t, right? So from here you can find omega first. This is the radian frequency, okay, we can get. Omega naught is given as 2 pi. And what is omega naught? You can write here, this is 2 pi f naught equal to 2 pi, right? What is f naught? F naught is a frequency in hertz, right? The reciprocal of frequency is going to be what? The time. I think f time only, right? So f naught is going to be 1 by capital T. Okay. Just put here, so you will find that T is going to be what? 1. Okay, 1 second. So here the sine 2 pi t, only one signal is given. See, signal can be the combination of multiple signal also. It can be situation like this: xt equal to xt x1t plus x2t plus and so on and so forth. In this case, you have to be little cautious as well. In this case, because there will be many. See, it will be having one time period. It will be having one time period. Okay, and so on and so forth. Then you have to verify. Okay, if you want to claim that xt is a periodic signal, so this should be periodic, this should be periodic, all the signals should be periodic. Okay, if one of the signal is not periodic, then overall signal is not periodic. Okay, remember this is very important concept I am telling. Okay. Okay, so I will discuss the entire complete detail here. Okay, how to find the periodicity, okay, by having some examples, but for the moment understand the definition. Okay. Okay, so I will discuss. And suppose we have got the discrete time signal. Okay, I will discuss, guys, what is the best procedure, okay, how to find okay, that is very, very important. So for discrete time signal, remember, suppose we have got x of n, so x of n plus capital N could be the definition here. Okay, in that case capital T was there, and this capital N is the smallest time period. Okay, smallest one. Okay, time period cannot be maximum, it will be smallest always. Okay, so the definition of fundamental period is what? Fundamental period. In the exam, question will be asked for fundamental period, find the fundamental period or find the fundamental frequency. Okay, in 2013 one question was there. They gave xt equal to x1t plus x2t plus x3t. I mean to say, they gave xt equal to sine t plus sine 2 pi t, something they have given, right? And they asked what is the fundamental frequency. It was very easy. You can find the fundamental frequency just by taking the GCD of all the frequency, right? What is GCD? No, GCD. What is GCD? Tell me here. GCD का मतलब क्या होता है? Greatest common divisor, or you can say HCF. So these basic concepts you should know. I will tell you while solving the question. Okay. If capital T is a period of periodic signal, right? If capital T is a period of periodic signal, okay, then m times capital T is also a period for any integer m, is also a period for any integer m. M, right? So you can write here that x of t plus m capital T is equal to xt. This is also one of the definition of periodic signal. Okay, so if there are m times t periods, right, so what will be the fundamental period? The fundamental period will be the smallest period, the smallest time. Okay, smallest time, keep this in mind. Okay, suppose you have been given t, 2t, 3t, 4t, 5t. Which one is fundamental? The t is a fundamental. Okay, so these basic formulas you can keep in mind. The t is equal to basically like I have told you that the omega naught is equal to 2 pi f naught. So from here you can find here the T naught is equal to 2 pi by omega naught. So these are very basic formulas. Okay. Omega naught is a radian frequency and F naught is given in. Okay. I hope this makes sense. So multiple of all other period will be what? Suppose we have been given a period T, which is fundamental period. So what will be all other period? They will be 2T, 3T, 4T, and T. Okay, so this is what the multiple of fundamental period, right? You can say always, right? Multiple of fundamental period. Okay. So if you have been given many periods, so you can always go for LCM. Okay. So there are various methods which I will discuss how to find a period if signal is periodic. Okay. But before that you need to test whether signal is periodic or not. तो मैंने क्या बताया कि मान लो तुम्हारे पास 10 एप्पल्स हैं, ठीक है? तो 10 एप्पल्स में क्या होता है, अगर एक एप्पल खराब है तो आप उसको खराब ही बोलोगे, राइट? सारे एप्पल खराब हो जाएंगे ना, everybody. Okay, so xt is given as x1t plus x2t plus x3t. So you have to check whether the overall signal is periodic. So if x1t is not periodic, then overall signal is not periodic, right? That you have to keep in mind. Okay, chalo, so periodic signal for discrete time also I have given you the definition. What was the definition? X of n plus capital N is equal to x of n. Okay, for all n, where n should be what, guys? N should be what? Integer. Okay, n is an integer number that everybody has to. Suppose somebody will ask you that suppose this is a kind of impulse signal. Okay, I will discuss why we call it impulse and all. So n equal to 0 is there and this is delta of n. Okay. If somebody will ask you that what is delta n minus 1 by 2, so can somebody find here what is delta n minus 1 by 2? Yes, can somebody find what is the value of what is delta n minus? Can you? So you have to shift it, right? But this shift should be integer also. You can't determine. This is a wrong question. Okay, so these kind of thing we will discuss as we move ahead. अब एक ही दिन में सारा नहीं हो पाएगा, ठीक है? This is not possible, that I want to assure you, right? So when we will discuss the operation on signals, like how to shift signal on time axis like this, you can shift left side, you can shift right side. Okay, you can scale signal. Scaling means increasing the magnitude. Okay, scaling the signal, scaling time. Okay, so there are many concepts we will discuss, ठीक है? तो याद रखना, this is for all n, for all n. Okay, so smallest n, this will be what? The capital N will be what? The smallest. So but one important criteria which you have to always satisfy. Okay, the test for periodicity for discrete time signal. Okay, this is very, very important criteria. What is that criteria? The omega naught by 2 pi should be equal to m by capital N. What is m by capital N? M by capital N should be always the rational number. Okay, rational number. What is rational number, guys? What is rational number? Rational number is nothing but the ratio of integer. Ratio of integer. Okay, very simple definition I am telling you. Ratio of integer. Okay, rational number is nothing but ratio of integer. So suppose we have been given a signal. Let me take one example here. So this is the test. Okay, always keep in mind whenever discrete time signal is given, so you have to put here omega naught by 2 pi equal to m by n, and this n will be what? The fundamental period. Okay, period. Let me tell you here. Suppose we have got a signal x of n equal to cos 2 pi n, right? Cos 2 pi n. Okay, what is omega naught? Omega naught is given as 2 pi. So can you put this into the test? So 2 pi by 2 pi is equal to m by capital N. What is the value here? This is 1 by 1. So n is equal to 1. Yes, because 1 is always rational. Okay, अब देखो एक क्वेश्चन है. सपोज xn is equal to cos 3n. Is it periodic, guys? By looking at this you can tell, is it not periodic? How? Test क्या है? Omega naught by 2 pi equal to m by capital N. So you can always go for like omega naught is what? 3 by 2 pi equal to m by capital N. Can you write this guy? Can you write this guy in rational number? No, because pi is there. Okay, pi is irrational one. Okay, this caution you have to always make sure, guys. Yes, what 0, right? No, you should say no. So cos 3n is not periodic. Cos 3n is not periodic. Okay, this is very, very important to understand, right? Cos 3n is not periodic. I hope this makes sense to everyone. Yes, and suppose, and one more thing, you just remember this format. Xn equal to cos 2 pi n by 15, right? So if somebody will ask what is the period here, so what you have to do always, what is omega naught? Omega naught is given as 2 pi by 15. Okay, simple. Now test. First of all, you have to check whether it is periodic or not. So test omega naught by 2 pi should be equal to small m capital N, right? So just keep the value here. So 2 pi by 15 into 2 pi equal to m by capital N. So this 2 pi gone. So what is n? N is 15. Okay, so guys, remember, whenever there is a 2 pi n and whatever is in the denominator of this argument, okay, that is going to be the period, right? So this is the period. If I ask you xn equal to cos 2 pi n by 31. So what is the period of this guy? Tell me here. What is the period of this guy? Tell me. The period for this equal to 31. That's it. Okay. The period for this signal is 31, right? Because it is periodic. If you check, it is periodic. So this is very important. Okay. In all that, you know, you will find in the previous questions. Okay. They will give you the question and they will ask. Okay. So here I am taking only one signal, that is cos 2 pi n by, and they might give you like this also. Xn equal to x1 n plus x2 n and so on. So suppose you have got n1 here, you have got n2 here, okay, and so on. So how to find fundamental? The smallest of all. So least value you have to find, means you have to go for LCM of all these, L1, n1, n2, n3 and so on, right? So we will take that kind of a question also. Just understand what is the basic concept behind that. Okay? How many of you understood this? In fact, I can give you one more question. Suppose xn is given as cos 31, sorry, let me take something here, 62 pi n by 5. Can somebody tell me what will be the period of this guy? Yes, as this is periodic for sure. So you can always compare this x of n with cos 2 pi mn by capital N. Mn by capital N, that's it. So find mn. What is m by n in this case? M by n will be, just take, from here you take 2. So it will be, you can say 31 upon 5. So answer will be what? 5 only. Okay. This 5 is going to be the answer for this question. Yes. So it is very simple, but many students, they, oh my God, it is very tough question. Okay. So remember, sometimes if x of n is periodic, fit in this formula, that's it. So m is what? The multiple of 2 pi. Okay, multiple of 2 pi. The denominator is going to decide the fundamental period. Okay. If I ask you one more question, see, I don't have any question list. I'm just randomly giving you the question, right? Because we understand the concept now, so we can frame question ourselves. अगर आपको concept clear है तो आप question frame कर सकते हो, ठीक है? उसमें doubt नहीं होने वाला है. अब आपको कोई, you don't have to apply any formula here, right? See, cos 10 to the power 6 pi n by 5. Can somebody tell me what will be the I think yes, 1 minute, it should not be, let me give you something, 31, or this is not okay. We can take 20, 42 pi t by 9. So can somebody tell me what is the period here now? What will be period in this case? Sorry, it is n, not t. Okay. So now you can find out. So test for periodicity of discrete time signal is what? Omega naught by 2 pi equal to m by capital N. Right? Okay. I hope this makes sense. एक बार सब लोग in the group, I mean in the chat box, everybody let me know if you have understood this concept, because this is very important. Yes. So I think yes, you guys can find out, right? So in this case you can find out what is m by n, that's it, and n will be the answer. ठीक है. In fact, I will further take, further explain you, because I'm just explaining x n is given as x1 only, right? But if there are many signals, then you have to find the time period for each, then take the LCM, right? So I will explain that concept in the next class only by taking some, examples, and I will give you the formula as well. The systematic approach, right? Next sort of classification I'm going to discuss is, guys, the energy and the power signal. Okay, energy and the power signal, before we wind up the session as well, right? Energy and the power signal. Now the question is, why do we discuss energy and power of the signal? Yes, why do we discuss energy and power of the signal, guys? See, the main reason is we want to know the strength of a signal. A signal, whatever signal you are sending, guys, what is the strength? Okay, so that it can fight with the noise, it can fight with the attenuation. आपको पता है जब आप सिग्नल यहाँ से भेजते हो तो क्या होता है? सिग्नल गेट्स attenuated also. ठीक है, तो आपको एनर्जी एंड पावर सिग्नल का आइडिया होना चाहिए. ठीक है, तो एनर्जी एंड पावर ऑफ द सिग्नल, वेरी इंपॉर्टेंट क्लासिफिकेशन. ठीक है, so what is energy signal? Remember, how do we determine energy signal for continuous time signal? Remember, okay, so suppose xt is the continuous time signal. Okay, continuous time signal. In the exam they have mentioned xt is a continuous time signal. क्या? xt is a continuous time signal. Okay, so the very first job you have to do is you have to take the mod of xt first. Okay, you have to take the mod of xt. देखो, in the exam they will not mention the xt is a real valued signal. See, if xt is a real valued signal, it's okay, you don't have to take mod. If xt is not a real valued signal, it is a complex valued signal, then you have to take the mod as well. But always make habit, okay, of writing the formula for energy signal is, first of all, take the mod of xt, then square of this guy, okay? Because you know the relation of power, okay, in case of current, voltage and resistance, right? I square r is the power, right? So we can also find the energy from there, right? So energy is defined in the same manner, right, here also. So xt is a signal, so first of all you have to take the mod and square of this and integrate from where to where? Integrate from minus infinity to infinity dt. Okay, this is called the energy of signal. Okay, so your integration is running from minus infinity to infinity. सबको समझ आया क्या? Everybody understood or not? Everybody understood or not this? ठीक है, okay. So Tanishq, you have to also cancel it, right? 21 by 9, further simplify it. Okay, standard form you have to do. Rational numbers should be in standard form. Okay, standard form means no common ratio should be there, everything should be cancelled. Okay, and the denominator is going to decide the fundamental period. ठीक है, याद रखना. तो ये डेफिनेशन है, ठीक है, ये डेफिनेशन किसकी है? एनर्जी की. कैसे एनर्जी फाइंड करते हैं, ठीक है. अब एनर्जी सिग्नल हम कब बोलेंगे कि ये गिवन सिग्नल इज एनर्जी सिग्नल? जब ये जो इंटीग्रल है वो क्या होगा? लेस देन इंफिनिटी होगा. ओके, जब ये लेस देन इंफिनिटी होगा, then only you will say that the signal is even energy signal. How? What is the meaning of this? See, if any signal is there and if you're trying to find the what? If you're trying to find the energy and you got energy as finite, so obviously you will say this is a energy signal और कुछ भी नहीं है. ठीक है, अगर मान लो ये इंटीग्रल डाइवर्जेंट हो गया, इनफाइनाइट हो गया, then that is not the energy signal. It is very simple definition, guys. These are the formal definition. क्या करना है? सबसे पहले mod लेना है, take the square, integrate from where to where? minus infinity to infinity. ठीक है, कितना अच्छा definition है. चलो, if I go for counterpart of discrete time signal, you know how to find energy for discrete time signal. See, x of n will be given here, right? And this guy is discrete time sequence. Discrete time sequence, right? So what you have to do here is, what is the first job, guys? First job is take the mod, then square of this guy. Why we are squaring? You know, I square or v square. See, you can consider xn is voltage or current, right? If you are from electrical engineering or electronics engineering, so we always consider इलेक्ट्रिकल सिग्नल्स, राइट? ठीक है, कि मतलब सिग्नल कैन बी वोल्टेज, सिग्नल कैन बी करंट, जो हम लोगों को पता है. प्राइमरी, सपोज वी आर स्टडिंग इन प्राइमरी स्कूल, राइट? वी नो ओनली करंट एंड वोल्टेज, राइट, बीइंग एनर्जी. सो जब आप पावर वहां फाइंड करते हो तो क्या करते हैं? स्क्वायर. तो दैट इज द रीजन वी आर डूइंग स्क्वायर हियर. ठीक है, कुछ लोगों को ये भी आइडिया नहीं रहता. गिवन अ सिग्नल, यू हैव टू फाइंड द एनर्जी, they forget to square of that given function or a signal, right? And in this case, in discrete time, the summation, the integration will become summation. Okay, so here the integration will become summation, and now summation will run from minus infinity to infinity. Summation will run from minus infinity to infinity. This is known as energy of discrete time signal. I hope this makes sense to everybody. सबको समझ आया क्या? ये डेफिनेशन समझ आया कि नहीं? बताओ पहले. ओके, चलो. तो when we can claim that the signal is energy signal. Remember, this is a very important concept, right? If energy is finite, what if the energy is finite? Finite means what? Energy lies between 0 and infinity. Energy is like this, okay? Don't say that, oh, energy is 0, so it's okay, energy signal, right? Energy, if it is lying between this, it should be always less than infinity, okay? If you have infinite energy, then you are not an energy signal. Keep this in mind. So, ideally it is, nothing can have infinite energy, but mathematically we are doing here, right? क्योंकि everything we are modeling, ठीक है, all situation we are modeling to understand, okay, to feel it. क्योंकि करंट को तो आप फील नहीं कर सकते हो. करंट कब फील करोगे? जब आई थिंक ओके एवरीबॉडी नोज, ओके, देख तो सकते नहीं हो करंट को भाई, ठीक है. तो इफ एनर्जी इज फाइनाइट, 0 less than E less than 8. Don't tell me 7/3, Tanisk. 3 is the answer. I'm asking 3 only. Multiple is different. Okay. So this, if energy is finite, then we call it energy signal. And we'll take various examples in the next class. Now the question is, what is power signal, guys? देखो, before you jump to the problem, let me frankly tell you, before you jump to the problem, clear your concept, guys. बहुत सारे लोग ऐसे होते हैं, उनका कॉन्सेप्ट नहीं क्लियर है, कॉन्सेप्ट पैदल है, राइट? बट वो, अरे प्रॉब्लम सॉल्व करना है, सर इज टेलिंग प्रॉब्लम, अरे ओके, चलो, आई हैव टोल्ड यू वन प्रॉब्लम, you have mucked up, next problem will be new, your concept is not clear, right? So first of all, understand the formal definition. Now, power signal, what is power signal? So in power signal also you have for continuous. You see here, first of all you have to take xt and then square mod of xt square, then integrate it from where to where, guys? Integrate it from minus t by 2 to t by 2 dt, and then average it. Average will be what is the average of this integration? You see, t by 2 plus t by 2, that is 2 t only, 1 by t, and then you have to apply the limit t tending to infinity. This is a average power, we call it, okay? We always evaluate average power, okay? So this is the definition. First, what you have to do, you have to just find what is this. I think everybody can understand. This is the energy of window signal, okay? Window signal means what? Your signal is finite duration. You see, from t by 2 to t by 2, right? Your signal is having finite width and the finite amplitude. You can say it is a window signal, right? Just find the energy, then energy by time is going to be the power, average power. So many people do not understand why we are doing 1 by t here. It is average, it is a process of averaging, okay? सबको ये फॉर्मूला समझ आया ना, ये डेफिनेशन जो है. Next is for continuous time signal, sorry, for discrete time sequence, x of n, okay? Now what you have to do here is you have to take x of n square. देखो, you have to learn the style as well, the way Dheeraj sir is doing, okay? Because you are approaching to IIT Bombay or IIT Bangalore now. After 5 to 6 months, your concept will be very good, okay? Remember. And okay, so you have to learn the style. So this is how we can do. Now this summation will not run from t by 2 to t by 2, right? It will run from minus n to capital N, okay? Now you have to average this guy, because we always find average power. So average will be what? 2n plus 1, because in this case 0 has to be included as. and limit from where to where? Limit will be from n to infinity. This is the average power. Okay, these are the definition. Now the question is, when you can say the given signal is a power signal? Very simple. Can somebody define when you can say the given signal is a power signal? It is simple. If power is finite. What is the meaning of finite? Okay, then you can say that given signal is a power signal. And what kind of power we will try to find? We'll try to find the average power. Average power. Okay. Okay. So what we are going to do here is in the next session, okay, I will be talking about some important continuous time signals. Important continuous time signals, and then we will take examples of power signal, energy signal, periodic signals, and solve for you, right? So what kind of continuous time signal we are going to discuss? Like UT, we call it unit step function, okay, or we call it Heaviside function as well. How to define, what is the formal definitions, right? We'll talk about delta of t. We'll talk about a rect ty capital T. Okay, so many kind of signal we are going to discuss. Okay, some standard signal we will see, so that we can make our journey smoother in entire course of signal system. So I hope this makes sense, guys. I would like to wind up session here, and you might have enjoyed a brief introduction to the classification of signal system, right? So if you have any doubt, ask, otherwise we'll wind up the session. Yes, मजा आया सबको? Yes, guys. Perfect. So if you have any kind of question, do ask me. Yeah. We will take the problem in the next session. I will take problem from Oppenheim. Okay. And each and every problem we will do. One problem I will do, I will ask you to do next. Okay. और पूरी बुक सॉल्व कर डालना है. सिग्नल का कोई भी क्वेश्चन आ जाए, बस हाँ, जैसे मान लो कोई स्टेटमेंट होता है ना, उसके एक एक वर्ड्स को आपको समझना जरूरी है. व्हाट काइंड ऑफ मिस्टेक वी ऑलवेज डू इज, एग्जाम में क्यों क्वेश्चन नहीं बनते हैं? देखो, जब क्वेश्चन आता है तो अपन को लाइन समझ में नहीं आती है. ठीक है, अगर आपको रियलिटी पता चल गई ना कि दिस इज व्हाट द पावर सिग्नल इज, दिस इज व्हाट द एनर्जी सिग्नल इज, दिस इज द रूट ओके ऑफ पावर सिग्नल एंड एनर्जी सिग्नल, सो लाइफ इज वेरी सिंपल देन. अब यार देखो, वही चीज है ना, क्वेश्चन है, बगल में शायरी है, तो आपका माइंड किधर जाएगा? शायरी में जाएगा, क्वेश्चन में नहीं जाएगा. ठीक है, तो फिर नहीं आने वाला है. ओके, आई होप दिस मेक्स सेंस, गाइस. विल मीट इन द नेक्स्ट सेशन एंड कीप लर्निंग. ओके, थैंक यू.